So this one's quite nice, actually. I like this one. So the numbers 1, 2, 3, 4, 5 are to be arranged in a circle. An arrangement is bad if it is not true that for every n from 1 to 15, one can find a subset of the numbers that appear consecutively on the circle that sum to n. Arrangements that differ only by a rotation or reflection are considered the same. How many different bad arrangements are there? And so we're trying to find, basically we're trying to find configurations for which one of these numbers is never like a subset sum. It's never like the sum of a subset of the values in the circle. But a lot of these are like non-starters. For example, 1 through 5 and 10 through 15 will always be there. Why? Like, why, you may ask, why am I guaranteed that 3 is the sum of a subset of the numbers that appear? You can just take 3. Same with 4, same with 5. Just by taking 1, 2, 3, 4, 5 on their own, which is guaranteed, which is something that you're guaranteed to be able to do. 1, 2, 3, 4, 5 appear, and then by taking, if at any point that like x is the sum of some subset, you can take the complement, you can take the set of the other numbers, and you'll get 15 minus x. So if we have 5, we can get 10 by taking the other 4. If we have, you can take everything except for 4 to get 11, everything except for 3 to get 13, everything except for 3 to get 12, everything except for 2 to get 13, everything except for 1 to get 14, and you can get 15 by taking everything. And in a similar way, these values are paired up. So 6, 9, and 7, 8 will both appear in pairs. So we have two choices. Exclude, if we want to make a bad configuration, we have to either exclude 6, 9 from ever appearing, or we have to exclude 7, 8 from ever appearing. And yeah, let's start when, if we're trying to exclude 6 and 9 from ever appearing, I'm going to consider 5, because you can make 6, 9, and 7, 8 very easily with 5. For example, 5, if its neighbor is 1, it'll make 6. If its neighbor is 2, if it has 2 as a neighbor, it'll make 7. If it has 3 as a neighbor, it'll make 8. If it has 4 as a neighbor, it'll make 9. So but 5 is a very strong place to start, because it's very hard to deal with there. So for excluding 6 and 9, that means that 1 and 4 can't be neighbors of 5. So the neighbors of 5 have to be 2 and 3. And then the neighbor of 2 can't be, and so now we have to order 1 and 4 over here. We can't have 4 over here because then we have a 6. So we have to put the 4 over here, and we have to put the 1 over here. And you can check, like try convincing yourself that 6 is not 6/9 aren't a subset sum of this. Because like 6 doesn't appear because this is 8. This is 7, this is 5, but you can't add 1 anyway to get to 6. This is 3, but you can't add 3 to get to 6. This is 7, which is already over 6. And then the other case, when you're excluding 7 and 8, that means that 2 and 3 can't be neighbors of 5. So that means that 1 and 4 have to be the neighbors of 5. And then now we're ordering 3 and 2. You can't have 3 over here because then that sums to 7. So this has to be 2, and this has to be 3. Once again, you can convince yourself that 7 and 8 don't appear here, and these things are different. So there's 2 possible bad arrangements. Yeah, so there's 2 possible bad arrangements. There's only 2 of them, and it's this 1, 2, 5, 3, 4 and 1, 5, 4, 3, 2. I remember when I first did this problem, like this is a long time ago. I think I tried to bash it. I like, I don't know how I did it. I was just flailing around trying random stuff. It wasn't very structured. Yeah, I think I tried. I don't think this might be the first time I've solved it actually. When I was doing it this morning. Yeah, bashing. You have to bash in the right way. Consider 5. 5 is the hardest thing to like. 5 will end up making. 5 will end up easily and like intuitive. Like pairs are easy to think about. Triples aren't.